Okay, here what we're going to be doing is we're just going to be utilizing Pythagorean theorem and in a variety of ways and its converse. To start, you basically just say, so this is question 1a, and it asks us to solve for the missing side length. So you're looking for this side length, and the whole thing is that you need to just be able to identify what's the hypotenuse, and this is the right angle, so opposite the right angle is always the hypotenuse. You have to make that side C. So we state Pythagorean theorem, and since this is a right triangle, we know that the legs, the sum of the one leg squared plus the other leg squared is the hypotenuse squared. So in this case, again, we just have to correctly identify which is the hypotenuse. That's this side with the 17 on it. So we make that C, we put 17 squared over here, and the side that's missing is this side over here. This we could call A or B, it doesn't matter, I'll call it B, 15 squared. So then this side is A plus B squared is equal to 17 squared. You want to solve for B squared. So you minus 15 squared on both sides. And here I'm illustrating just the strength of algebra that 15 squared minus 15 squared is 0. I don't even know what 15 squared is yet. B squared is equal to 17 squared minus 15 squared. And now B squared is equal to whatever 17 squared is minus 15 squared is. That means that B is the square root of 17 squared minus 15 squared. I just took the square root of both sides, because what's the square root of B squared? What number or what expression? Of course not. I don't know how that happens. And there we go. Okay. Okay, we're okay. Now, yeah, I mean, what is the square root of B squared mean? It means what expression times itself gives you this inside value, this B squared. Well, B times B gives you B squared, so therefore the square root of B squared is B. And then, you sit here and you do the calculations for whatever this is, and now you just have to do some arithmetic as to what this answer is. And if you want to leave it like this, I'll literally take off 1 point if you have just this as your answer. So the final correct answer would be to sit there and figure out 17 times 17, right? Write that in here. 15 times 15, write that in here. And then subtract. And then write it as a square root. Simplify the square root. So let's simplify the square root. Let's learn how to do that real quick. 10 plus 7. 10 plus 7. I'm squaring. It's 100 plus 140 plus 49. 240, 289. So 289 minus 225. 5 squared times 3 squared is 25 times 9, which is 125. And then I'm going to get 289 minus 125, 4, 6, 1, 1, 6, 4. And then I sit here and I say to myself, well, I know that this is going to be divisible by 4. So it's the square root of 4 times the square root of 16, 4, 41. Right? 41, 4, and then 60. This is 2 square root 41. And I know 41 is prime, so this is my answer in fully simplest form. So if you leave it in this form, let me be very clear, I'll give you 8 points, because this takes some time, so the ability to do this needs to be worth more than 1 point. So it's 8 points out of 10 if you leave it like this, if you solve for B as this expression. Okay, now let's do another one. So let's go back and let's reiterate this process again for another one. So now I have, let's say, I don't know, let's take one where that was that. Okay, so let's say 1C. 1C, I take this, I have this right triangle here. This is 24, 10. And again, the numbers are going to be really high in this case. Okay, I'm going to try and avoid that on your quiz, but let's just tackle it. What is the answer? A squared plus B squared is equal to C squared. Okay, in this case, we have to identify C as the actual missing side length, opposite the right angle. And I have now 10 squared plus 24 squared is equal to my missing side squared. 10 squared is obviously 100 plus 24 squared. 24 squared is 20 plus 4 squared, and then that's going to be 400 plus 80, 160 plus 16, 560, 576. I'm just going to do it again. 20 squared is 400. 20 times 4 is 80, times 2 is 160. 4 squared is 16. This is 560 plus 16 is 576. So I'm going to write this is 576 is c squared. Then I'm going to get that c is equal to the square root of this whole thing, 100 plus 576, which just means that c is the square root of 676. Now I'm going to have to squint at this. Is there two 2's that I can fit in? Is this number divisible by 4? I do know that if I took my time, I'd find out that this number is divisible by 4. So I would rewrite it as that c is equal to the square root of 4 times whatever, this is going to multiply to. So how many 4's fit into 676? 1, so 1, and then 4 to 27 is going to be 24, so 8, 16, 24, 8, and then 3, 36, and then 9, 189. And 189 might be a perfect square. I think it's 13. No, it's not. What goes in? 9 goes in. So square root 4, square root 9. 9 goes into 189. And again, you just have to sit here and find the largest perfect square. 9 is a perfect square. That goes in. It's going to be 2, 18, 0, 1, 9, 1, 21, square root 21. And then the square root of 4 is 2. The square root of 9 is 3. So this becomes 6 square root 21. And that's as much as you could simplify it because 21 doesn't have any other perfect squares as factors. The hardest part in this, look, you get c as, the square root of, you get c as the square root of 676, 8 out of 10, okay? 8 out of 10, because this takes some work to sit here and simplify it to this. So I got to make it 2 points. Now, let's do the next type of problem where we got to know how to do the algebra, and that's what's key here. So if I have, let's say, so number 2a, right? If I have, let's say, a triangle, and then I say that they're in some configuration. So let me get a good configuration here. Of course, I don't know. Time here. Okay, so let's say I have that this is x, this is gonna be let's say x plus 7, and then this will be x plus 8, and your goal is to solve for x, right? So what we need to know is that it's not too different than just solving it in the case where it's numbers. Now here we have algebraic expressions for these numbers. So the first thing you want to be able to do is identify which side is c. This is a right triangle, so we know a squared plus b squared is equal to c squared. So let's identify which side is c, opposite the right angle. So this x plus 8 is c, so I'm going to write x plus 8 squared over here. Then a is like x, and then b is like x plus 7. And now with this, you gotta do this algebra out. So the x squared you can't do anything with, you leave it. But this x plus 7, right, squared, you FOIL that. And if you know the rule right away, a plus b, any a plus b squared, right, if you have this in your mind, it's a squared plus 2 times the multiplication of a and b plus b squared, right? You can rewrite this now. This is just going to become x squared plus 2 times 7 times x is 14x, right? Plus 49. You guys should see that if you FOIL it out, you get this. Similarly, I'm going to do this quickly. X squared plus 16x plus 64. And then now I have an equation with quadratics, right? So I'll simplify both sides. This is 1x squared. This is another x squared. That gives me 2x squareds plus 14x plus 49. And that's as simple as I can make the right-hand side, the left-hand side. And the right-hand side, I can't simplify any further. So I just simplified a little bit to make it a little bit easier. But now, since you're trying to solve an equation with square terms, meaning that it's a quadratic, what you basically want to do is you want to get one side equal to 0. And it's going to be much easier if this squared term is positive. So I'm going to move everything over. This 1x minus 16x minus 64. And then this whole side becomes 0. So I minus an x squared on both sides. I minus a 16x on both sides. And then I minus a 64 on both sides. This is 0. X squared minus x squared is 0. 16x minus 16x is 0. 64 minus 64 is 0. 2x squared minus 1x squared is 1x squared. 14x's minus 16x's is negative 4x's. And then 49 minus 64 is negative 24, negative 25. Okay, and then now you have this quadratic equation to solve. And this is in the nice form. This isn't, you know, this you could use the quadratic formula if you know it. You could factor it if it's factorable. Or you could complete the square. There's a whole bunch of methods of now solving this quadratic. Okay, so here, right, what's the goal for factoring when it's, you know, when the coefficient, right, this coefficient is 1. That's an imaginary 1 there. And when that happens, you could factor it in a nice and easy way. You could write it as x like this equals 0. And the answer for what goes in these slots is what multiplies to negative 25 but adds to negative 4. So what multiplies to negative 25 but adds to negative 4? Is there anything? Did I do something wrong? Yep, this is supposed to be minus 2. Net 14x minus 16x is negative 2. Good. Okay, multiplies to 25 and adds to negative 2. Still nothing. What did I do wrong? 50 minus 64. What is this supposed to be? I'm doing this too fast. 49 minus 64. Is it 25? No. What is it? It's going to be, okay, so I check my work. I'll always make it so it's factorable. So you know you've messed up at some point. Minus 2x like I did. 49 minus 64 is going to be 14, 5, 15. Negative 15 is equal to 0. And again, same thing though. You factor it like this. X times x equals 0. And then now I ask myself, multiplies to negative 15 but adds to negative 2. Minus 5, positive 3. And the thing here now would be to say, well, what makes this equation true? If I make this factor equal 0, if I find an x that makes it so this is 0, 0 times whatever is left is going to be 0. So all I have to do is make it so x minus 5 equals 0. Or that x plus 3 equals 0. What that guarantees is that x should equal 5 or x could equal negative 3. Now, if x equals negative 3, then this length doesn't make any sense, so we reject this solution. And x being 5 is the correct answer. Then that means that this is 12, this is 13. And this does fit into being a right triangle. Okay. Now, the next one's easier. Let's go through it because it's an algebra one. We just did some algebra, so let's do another algebra one. We have here, and this is a right triangle. Put that in on your paper. I didn't put that in. 7. And then r plus 1, right? So what is it? Use Pythagorean theorem. R squared plus 7 squared, or you should write Pythagorean theorem to start. A squared plus b squared equals c squared. You should know that the c term is r plus 1. So it's 7 squared plus r squared is equal to r plus 1 squared. Now you have 49 plus r squared is equal to r squared plus 2r plus 1 when you FOIL out. You minus r squared on both sides, you get 0. And then now you minus 1 on both sides, you get 48 is equal to 2r. And then that means that when you divide by 2, you get r is equal to 24, and you're done. R is 24, and then this is 25, this side. Okay, because it's just r plus 1. Okay, now let's see. Let's go on to the next type of thing. Okay, so the next type of one, okay, let's just convince ourselves of how to do this. So I have this triangle here, right? It's not drawn to scale. This is an isosceles triangle. It's 14, 14, 16. And I'm just going to convince you of a given statement here. We know for sure that every single segment has a midpoint, including this segment right here. So since it has a midpoint, let's call that midpoint right here. That means that this is 8 and that this is 8 right here. if I draw this line going down, right, we should convince ourselves that the triangle on the left and the triangle on the right are congruent, right? This triangle is the same, the left triangle is the same as the right triangle. And since this was a straight line and these two angles are congruent, we should convince ourselves that these are right angles. Okay, that's what enables us to actually solve for the area. Because what is the area of a triangle? If I have this, right, this is the height, right? So let's go back. Let's make sure we understand. Let's make it, this is a right angle, and then this here like that, right? What is it? This is h, this is an altitude, and then this is the base. And the area of the triangle is base times height by 2. So here, this is taking the role of h, right? Because it's a right angle. It just has to be a right angle from here down. That's why I wanted to convince you that these were right angles here. Now, with this fact, okay, how is it that I'm going to solve for what this actual length is? And that's why this is an application of Pythagorean theorem. Because this now is a right triangle. Look at this left triangle. It's 8, 14, and then this is the unknown that we need. This is h. Okay? And if we look at that, we do that like how we did the other problems. We look at this right triangle, we say, well, this 14 is the c squared. So I have a squared plus b squared is equal to c squared, where a or b is like h. So I could write h squared here, I don't care, but I'll substitute in, one of them for as h. So a is 8, so that's 8 squared, plus b is like h squared is equal to 14 squared. And then I can solve for h, because then I'm going to get, when I minus 8 squared on both sides, right, this cancels, I got h squared. Then h is equal to the square root of 14 squared minus 8 squared. And then I sit here and I do the arithmetic for what that is, and I get this length. So let's figure out what that is, so I can get the area of this triangle, which is what it's ultimately asking, okay? So the area for the triangle then is going to be 14 squared is 7 squared times 4. 7 times 2 is 14 squared is 7 squared times 2 squared, which is 49 times 4, which is 50 times 4 minus 4. 50 times 4 is 200 minus 4 is 196. So this is 196 minus, so the square root of 196 minus 64. So I was making mistakes before, so let's be a little more careful. 2, 3, 132. So this is the square root of 132. Now, since that's the square root of 132, is 132 a perfect square? No, right? 132 goes into, it's definitely 4. 4, and then what's its partner? 3 times it goes in, and then there's 1 remaining, 33. And then this is 3 and 11, and that doesn't help, so it's 2 square root 33. Okay, so then this length is 2 square root 33, if I did that right, which I'm debating right now. 4 times 30 is 120, plus 12 is 132. Okay, and then now, so yeah, it's this 33, and then 33 is 3 and 11, so there's nothing else. So then yeah, so this is 2 times the square root of 3, and then this length as a whole, this base, is 16. So your final answer you could leave as a square root, which is going to be 16 times this divided by 2, right? Because now I have the base, which is 16, and a height for the original triangle. So the area is equal to 1/2 base times height. I just solved for the height. The base is 16 times the height is 2 times square root 33. 16 by 2, just do that, is 8 times 2 is 16 again. 16 square root 33 is the area of this triangle. Okay, the other one is obviously just the very same concept. Let's go on to number 4. So now 4. 4 says, okay, let's write out all of 4. You have to read this problem carefully. So 2 vertical poles. 2 vertical poles are 5 feet apart on the ground. 1 is 10 feet, and the other is 22 feet. Okay, a rope is extended between them. How long is the rope? How long is the rope? So it's right there what you guys have. I just rewrote the question because you want to really focus on the reading comprehension and interpreting that. So I have 2 vertical poles, okay? And they're 5 feet apart on the ground. So this is one vertical pole, let's say, okay? And then here's another vertical pole over here. And I'm basically telling you that this length is 5 feet. Okay, so they're 5 feet apart from one another. One is 10 feet tall, so this is 10 feet right here, right? And then the other is 22 feet. So the taller one is 22. So this is 22 feet. Okay, and then the other one is 10 feet. Okay, and then we have this rope, which is the key. This is what we want to find. We want to find the distance, this length of this rope. And you see that I'm already drawing this line here to illustrate like what we're going to be really doing at the end of this. So we want to find that blue length, but we should see that the dotted length, first of all, this is a right angle, right? They're vertical off the ground. So that means that they form a 90-degree angle with the ground. Here's the ground, right? This is the ground. And this is, of course, a 90-degree angle. If you sort of like draw that line going across in your mind, you should see that then this is going to be a right angle where it's parallel to the ground, right? You should say corresponding angles. 2 lines are parallel, but okay, whatever. You should kind of see where this diagram comes from. And if you can't, just sit there and just try over and over again. Really envision 2 poles in the ground, right? And then like be like, all right, now I'm stringing a rope between the 2, right? And then say, okay, now let me turn it and kind of look at it the right way. And then say, okay, this here, if I draw that, it's going to be a right triangle right here. Now, in this right triangle, right, let's look at the right triangle that's going to be of relevance to us. This is going to be the right triangle that's of relevance to us. Because this is the right triangle that's going to enable us to solve for the rope length, this length right here. Okay, this length is 5 feet. And then if you see, this is 10. So then that forces what remaining length is here. That's the trick in this, right? It's not 22, right? We need to have an idea of what that length is. And the remaining length is that you should see that this is 10 feet, right? So then that means that the remaining length is 12 feet. And this is a 5, 12, 13 right triangle. And if you don't know, right, how did I get the 13, right? Okay, I just did Pythagorean theorem, but I knew it right away. But that's fine. Let's do it. So we have this triangle, and I'm looking for the hypotenuse in this right triangle. So this is 5, this is 12, and obviously it's not drawn to scale because this side is not shorter than the 5, but okay. Then we see that I'm looking for this side. That's the length of the rope. So it's going to be a squared plus b squared equals c squared, and I have 5 squared plus 12 squared is equal to c squared. This is going to give me 25 plus 144 is equal to c squared. This is going to give me 169 is equal to c squared. Take the square root of both sides. The square root of 169 is 13. And I have the length of the rope, 13 feet. And that's it for that one, okay? The last thing is us using the converse theorem, right? So here, we got to remember what the converse theorem states. So the converse theorem states that if you have, if a squared plus b squared is equal to c squared in a triangle, then the triangle is a right triangle. Okay. And basically what you have for like A, right? 9, 12, 13. That's a good one to do. And then let's do B. Yeah, B is fine. 1 square root 3 square root 2. And here, what you do is you always make the longest side c. So you need to find out which one is the greatest of the three numbers. It just so happened that it was the last one in this one, but don't assume them to be in order. In this one, right, this is the greatest number. So make that c and see if the equation is valid. If this equation is true, then it's a right triangle. But if this equation is false, then it's not a right triangle. So I need to ask myself, is 13 squared equal to 12 squared plus 9 squared? Right? That's the question that I'm asking. So 9 squared is 81 plus 144, and then 13 squared is 169. 81 and that is going to be what? 81, 5, 12, 225. So 225, is that equal to 169? No. So this is not a right triangle. Not a right triangle. Okay? And then now let's see in this one. So now, again, I first would have to identify what the longest side is and make that side c. So it's a squared. I'm trying to see if a squared plus b squared equals c squared, with c the square root of 3. The square root of 3 squared is just 3. Right? B squared, doesn't matter whether you make this b or a now, right? It won't matter. The equation will be true or not in the same way. So 2 plus 1, because if b is the square root of 2, the square root of 2 squared is just 2. Does 1 plus 2 equal 3? Yeah, 3 equals 3. So this works out, right? Look, the square root of 2 squared plus 1 squared is equal to the square root of 3 squared. 2 plus 1 is 3. And now I'm done. I have it. That's it. Okay, and that's everything from the homework. Ugh.